So there's just a quick update on my CPM single board Z80 computer, which has been on breadboard for so long now that it's starting to get dust all over it. So it's time to move it off this breadboard and get it onto a proper PCB, which I'm currently in the process of designing. But let me just give you a little tour around the circuit and I'll show you what it does. So we're running here a Z80 CPU. We have got an EEPROM, which is used to just boot the computer up. We've got 64K of RAM here. We've got a little bit of glue logic to connect various things together. I've got an Arduino Nano here, which is acting as a virtualized set of peripherals. So I've virtualized the keyboard, so that's working through my computer keyboard over USB. I've virtualized the screen, so I'm using the computer screen, so anything this little computer wants to print, it prints onto my computer screen. And I've virtualized the disk drives as well onto this micro SD card in this micro SD card holder at the back. So it's a really, well, can we see what that is? I think it's 1 gigabyte. It's not even that, is it? It's 128 megabytes. It's a really ancient micro SD card, but it's more than enough for what I need, which is to be a set of floppy disk drives, effectively virtual floppy disk drives for my CPM computer. Also, here's the clock down here. That's 4 megahertz clock with this little. That's a bit bad how I've done that with those two resistors. I haven't even cut the leads down short, but there's a 4 megahertz crystal in there, and I've got a couple of lights. Well, it's actually this is a 10 LED block of 10 LEDs. I'm only using 2 of them. The one on the right hand side is the boot LED, which only comes on when it's booting up to show that the ROM is enabled for booting, and the other LED shows you whether there's any traffic between the Z80 and the Arduino. So basically any requests for keyboard, screen or disk access will bring that on. And I've got my power supply, which I've set to 5.2 volts because I found I was getting a bit of voltage loss here, and it was actually the circuit was running at less than 5 volts, so I set it to 5.2. I connected up 2 lots of wires, 2 black wires and 2 red wires through to this breadboard, but it seems to average out at about 5 volts when I run it at 5.2 volts, so I think there's a bit of solderless breadboard power distribution losses there. So if I press the reset button and we're watching it on the on Minicom, which is the terminal that I'm using to view what goes on this computer, you see that I've got an Arduino helper, which is a message coming from the Arduino, and then I've got the CPM sign on message for CPM version 2.2. So this is 2.2, which is probably arguably the most common version of CPM. And then I've got my, here's my keyboard here. This is my Mac keyboard, which I'm typing on, and whatever I type comes through the USB cable into the Arduino. And when the Z80 program asks for a key, it gets the next key from the Arduino. So I can type, so say dir, and there's what I've got on my A drive. There's a few things I've been just messing around with really, and so every time the Z80 wants to print something, it sends it to the Arduino, and the Arduino sends it through the USB cable into the screen. And we're running at a decent kind of speed at the moment. I've got an A drive, I've got a B drive, and I've got all the way through to a P drive. So in fact, if I just go to the O drive, which I don't think's got anything on, and type stat, we should see the size of the disks, and the O drive's got nothing on. I think it's got nothing on. Let's just double check. Oh no, it's got a Lords of Time is a level 9 adventure game that I was playing around with. But I think I've configured them to be 788K disk drives. Let's see if I can do this. C is a program that I got. Oh, 784K. There you go. So there's 784K disk drives. And I'll just give you a quick overview of how this whole thing is working. First of all, if I just take out this SD card from here, take out the SD card, we'll put it into the computer And let's take a little look at that. So on this SD card, then I've got a folder called CPM, and in there's a folder called disks, and in there I've placed one folder for each folder on my. I've created one folder for each floppy disk that I want to have on my computer. So if we have a look on there, the A drive, I'm not sure what these minus number ones are, but generally speaking, all these numbers represent tracks on the disks. I think there's a bug that's creating the minus numbers. So the folder 0000 will be track 0000 on the floppy disk, and within each track I've got folders representing the sectors. So on a floppy disk consists of a series of circular tracks, and each track is split into a series of sectors, and each sector is 128 bytes long. So this is based on the whole CPM concept that every disk drive in the entire world is split up into tracks and sectors that are 128 bytes long, despite the fact that they aren't. But anyway, CPM sees the world in terms of 128 byte sectors. So when CPM wants to store something onto disk A, it tells the Arduino that it wants to store something in, let's say, track 15, sector 5, and the Arduino dutifully stores the 128 bytes that that CPM sends it and puts it on there. So that's how I've virtualized my floppy drives A to P. The reason there's 16 drives A to P is because that's the maximum number that CPM can cope with. So let's look at how I got hold of CPM itself. CPM is obviously pretty ancient, and the CPM source code is available on the internet in various different places. I found online the source code for CPM in two different versions, actually. This one was produced by Clark A. Calkins in 1981, and it seems that what he did was he took a working version of CPM and he passed it through a disassembler and disassembled it to 8080 style source code mnemonics. So basically the 8080 processor, which was the predecessor to the Z80. And I found this version of CPM in various different places on the internet. And well, it needs converting to Z80 mnemonics or Z80 mnemonics in order for me to be able to use it. And also, it had a few mistakes. Well, just bits where it hadn't translated properly, I think, which I had to fix up. Now, CPM is comprised of three parts. The highest or possibly lowest level part, depending on how you look at it, is the BIOS. There's also the BDOS, and there's the CCP. So the CCP is the part where you actually type commands in. So you type in something like dir and or you type the name of a program. So if you're going to play the game of Snowball, you type in Snowball and it loads up Snowball. That's sort of the command processor. It's called I think it is called the console command processor. The BDOS is really the heart of CPM, and that is where all the disk access takes place, and it's in control of things like keyboards and screens. And the BIOS is the absolute lowest level part of CPM, and it just deals in very, very low level things like key presses, keys going to the screen, tiny bits of information going to the disk, and tiny bits of information coming back from the disk. Now, when you get hold of a copy of the CPM source code, you'll get all three parts of it, the CCP, the BDOS, and the BIOS. You leave the CCP and the BDOS exactly how it is, but you tune up or reconfigure or rewrite the BIOS to match the hardware that you have got. So in the case of my computer, what I had to do was get hold of this CCP here, get hold of this BDOS, which is in this file here, and get hold of the BIOS, which is in this file here. I had to rewrite the BIOS implementing a set of routines. So it's got, how many routines is this? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 routines. So there are 17 very, very basic routines in the BIOS that you need to implement in order to run CPM. And that is really the genius of CPM, that there are just 17 basic functions. You need to tell your system how to perform those functions. Once you've done that, the whole of CPM just sits on top of that and works. And even then, you don't need to implement all of them. So for example, this command here, BIOS list, that's for printing things out on a printer. Well, I don't print anything out on a printer, so I didn't bother implementing that one. You've got a punch card. I think that's the punching bit, and that's the reader part of the punch card. Reader, didn't bother implementing those. There's one for finding out the status of the printer. I didn't bother implementing that. And there's a sector translation one, which is only used by real floppy disks. You don't need to use sector translation on a virtual floppy disk because it's just to do with performance increase of floppy disk drives. So I didn't implement that one either. So it only leaves you with about a dozen things that you need to implement. And so you implement a boot routine, you implement one for sending a character to the screen, you implement a routine for getting a character from the screen, and all the rest of CPM sits on top of that. So let's give you an example. Let's look at here's one for, oh, it's got some rubbish code. Here's the console in one, for example. All it does is gets a key, which I'm doing by an out command to ask my Arduino for a key, and then an in command to get the key from the Arduino and returns it back to CPM. So they're reasonably simple. I think the most complicated one is probably the one to do with the disk drives. Here's the one to read 128 bytes from the disk drive, and I've got one to write 128 bytes to the disk drive. But they're all pretty simple things. And this is really the clever bit about CPM, that if you make a completely new computer that doesn't correspond to anything that's been used, any existing computer, you can still get CPM running on it. All you've got to do is implement these BIOS commands. Now, the BDOS sits on top of the BIOS, and this version, I did have to modify it very, very slightly, just because I wanted to make it a little bit more friendly. I've just improved a couple of features of it, but very, very little. And this also implements a set of functions, a much more sort of rich set of functions. So for example, you can ask it to open a file, close a file, create a new file, look for things on disk, change to a different disk, etc., etc. And it does these functions by calling things in the BIOS. And then on top of that, or below that, depending on how you look at it, you've got the CCP, and that implements, let me see if I can find them, it implements a very small sequence of instructions, one of them being dir, so let's search for that, there we go. It implements dir, erase, type, which types a file out on the screen, like show, I suppose you call it, or dump. It's a very basic save command, rename, user, which changes the user, and 3 extra commands which I have added to it, which I'll talk about at another point. And it also allows you to load a program off of disk and run it. So, for example, when I type the stat command to see the status of a disk, that isn't one of the built-in commands, it's one of what they call the transient commands, but basically a command that's in a program on disk, a COM file. It loads in that program and runs it. If I type in dir, it runs one of the... Oh, I took the SD card out, didn't I? Let me put that back in. That's going to upset it. Right, let's reboot. There we go. So if we type dir, that's a built-in CCP command. So that's going to do a dir. It's going to do that. So the CCP calls the BDOS to ask it various different things, to do a directory listing, the BDOS calls the BIOS, and the BIOS talks to my Arduino and gets things off of the disk and sends them to the screen and gets keyboard commands, that kind of stuff. If we type stat though, which is a program that's on drive A, like there it is, stat.com. So if we type stat, that program stat.com is loaded into memory and run, which is why it takes a little bit longer than dir takes, and tells us how much space is on the disk. And if we type stat disk, it tells us more detailed statistics about the disk, such as its capacity and various different things about how many records are on it. This computer seems to be running reasonably stably actually at the moment at 4 megahertz. So I can start up, for example, let's see, we've got, let's get a P drive, I've got Lords of Time on there. Oops, let's try and spell it right. Which is quite a good adventure, well, when I say good, for its day, quite a good adventure game, which I haven't beaten actually yet. I might have to play on that. Now it takes a little while to load up, but there you go, please enter your name. Well, I think I can answer that one. From level 9 computing. And it's pretty good. Let's go north, shall we? We're in the living room. A fine golden hourglass. Oh, we'll examine hourglass. Ooh, take that then. Take hourglass. Ooh, what's in my inventory? I've got a fine golden hourglass. What now? Quick. 25 out of 1,000. So that's working quite nicely. What else have I got on here? I think I've got Microsoft Basic. I've got T Basic, which is a very small basic. It's like a very tiny basic, in fact, which is working quite nicely. Let's do the classic print. Hello world with the comma. 20, go to 10, run. Hello world. So that's working. How do you get out of that quick? I think that's working very well. I have got various different compression and decompression programs because they're very important in the world of CPM for some reason, probably because everybody's disk was really tiny. Basic 5, I can't remember what that is. Basic 5. Basic 5 interactive interpreter from 1977. Version Z 1.0. New or old? I think we'll have new, thanks. Ooh, capitals only. New program name. Ready. Let's try this one out. 10. Print. Goodbye world. Is that how you do it? Yeah. 20, go to 10, run. There you go. That runs pretty quick, doesn't it? Ooh, how do you get out of this one? System. Right, so yeah, it all seems to be working nicely. I had a few problems getting this thing set up and getting it going, but it does all seem to be very, very good. The only thing I've not managed to do, which are my last two goals really for this, one is I want to get a C program compiled. So I've got a C compiler somewhere on this. Is it that? C.com? Anyway, I've got a C compiler on a high-tech C compiler that I'm trying to get running. And also I've got Zork, which sort of works, but not quite. So Zork 1, I can't understand why this doesn't work. So the rest of the system seems to work quite well. Maybe it fills up the memory and overflows or something, I'm not really sure. But this isn't running massively stably. So yes, it looks like it's loaded up. Zork 1, the Great Underground Empire, 1982, Infocom. But if I type look, it tells me brief descriptions, which it shouldn't do. So I'm not sure what it's talking about there. And if I move around a little bit, eventually it crashes. Forest path, forest path, but eventually it crashes. So I'm not sure what's going on with that one. Needs a little bit more investigation. So yeah, to summarise, I'm very pleased with this CPM system so far. Seems to be running quite nicely. Just a couple of little tweaks, but I want to get it off of breadboard onto a PCB that I'm making, and just get the whole thing off of this strip board, because I know this breadboard, because I know what's going to happen. I'm going to accidentally pull a couple of the wires out, or it will just stop working, because things like this always just stop working because of these silly wiggly wires everywhere that I should have done more neatly than I've actually done.